Hello everyone, welcome back to my channel Alisha Chemistry Class for All. Today I am going to take the third class of acid base chemistry. We have already learned two classes, class 1 and class 2. Class 1 is totally depend on concept of acid and bases, which is basically the two concepts, Arrhenius and Lowry-Bronsted, and second class is all about Lewis base, and today's class is only focused on solvent system theory, which is a very important theory of acid and bases. So it is nothing but the extension of Lowry and Bronsted concept. So let us try to explain the today's class. Students, listen carefully. It will be very helpful for you in future. So what is written here? The theory is today's class is solvent system theory. So the solvent system concept is extension of Lowry-Bronsted concept. It is the extension of Lowry-Bronsted concept means in Lowry-Bronsted concept we have learned the acid base property is depend on only aqueous solvent. It can explain it can explain the acid base property in aqueous solvent only, so it is only applicable in aqueous solvent. But in the solvent system theory you can explain the acid base property in protic as well as non-protic solvents. So this is nothing but the extension of Lowry-Bronsted concept of acid and bases. It covers aqueous as well as non-aqueous solvent like ammonia, HF, acetic acid, H2SO4, hydrogen, liquid sulfur dioxide, etc. You can explain the acid base property in different types of solvents. It may be protic or non-protic, doesn't matter. All of you know each and every solvent has a property of auto-ionization. Auto-ionization means two molecules or three molecules will dissociate into one part will be cation and another part will be anion. This is known as auto-ionization. Say for example, water molecules. One water molecules can donate H plus ion, and this H plus ion can accept by another water molecule. So two water molecules will dissociate to form H3 plus and OH minus. So this is called auto-ionization. Auto-ionization of the solvents. This concept was put forward by Caddy and Elsey in 1928 and extended by Franklin. So this is the introductory part of solvent system theory. Now we move to the theory. So what is the solvent system theory? To know this solvent system theory, first of all we have to know the auto-ionization of solvent. What do you mean by auto-ionization of solvents? So first we have to learn what is auto-ionization of solvent. All of you know auto-ionization means it will doesn't depend on the various factors, so it will be auto-ionized. Auto-ionization of solvents. Say for example, you can take any solvent, it may be protic or protic solvent. So two molecules will combine to each other, one will be decomposed to the cation, another will be form an anion. So this is called the auto-ionization. Say for examples, we are taking the simple examples, two water molecules. Here one water molecules will donate H plus ion and another water molecule will accept this H plus ion. If this water molecule accepts H plus ion, it will be converted into H3O plus and another water molecule is converted into OH minus. So one part is cation and another part is anion. So this is known as auto-ionization of solvent. So it may be protic or aprotic, doesn't matter. Say another examples of solvent, say ammonia. ammonia, liquid ammonia. So one molecules will abstract a proton, become NH4 plus, and another molecules donate H plus, and it will become NH4, NH2 minus. So this is cation and this is anions. So all of you know the cation means it is electron deficient center. Cations and anions means it is electron rich center. So in previous classes we have learned about the Lewis acid base concept. All of you know a Lewis acid is a substance which can accept the electron pair, and the Lewis base is a substance which can donate electron pair. So a cation is always acting as a Lewis acid and anion is acting as a Lewis base. So you can see here H3 plus can act as a acids and OH minus can act as a base. Similarly, NH4 plus can act as a acid and NH2 minus can act as a base. So this is known as the auto-ionization of solvent. I have taken only 2 examples. There are so many examples of solvent auto-ionization. I'll discuss in these classes how much possible. So now I move to the theory part. What is the solvent system theory? So to know the solvent system theory, we have to first know the auto-ionization properties of the solvents. So solvent will auto-ionize. One part will be cation and another part will be anion. I'm going to the theory part of this solvent system theory. So what is the theory? So acids are those substances which will decomposes itself or in solvent to increase the cationic part of the solvent. So acids are those substances which will decompose itself or in solvent to increase the cationic part of the solvent. Similarly, a bases are those substances which will decomposes itself or in solvent to increase the anionic part of the solvent. So acids will increase the cationic part of the solvent and the base will increase the anionic part of the solvent. So if there is any compound that will dissociate itself or in solvent to increase the cationic part, that will be acids in the corresponding solvent, and a base and a compound which will increase the anionic part of the solvent, that compound will be the base in that particular solvent. So now I am going to take some examples in different solvents. So whenever we are talking about solvents, so first water is come to our minds. So then water is the nature. Water is a solvents, universal solvents. So first we are taking the examples of water molecule. So water molecules auto-ionize. I have already written in before. Water molecules auto-ionize to H3O plus and OH minus. So this is cation and this is anion. So any compounds which will dissociate directly or in aqueous solution to increase the H3 plus ion concentration, that compounds will be acidic in water, and the compound which will be dissociated in which will dissociate itself or in aqueous solution to increase the anionic part, that will be the base in water solvents. Say for examples, very simple things, HCl when dissolved in water, that is dilute HCl, or it will be decomposes to H3O plus and Cl minus ion. So it will increase the cationic part of the solvent. Which solvent? Water solvents. So HCl will be an acids in water solvents. So it is basically solvent dependent acid base properties. So one molecules may act as a solvent, one molecules act as an acid in a solvent, but in the same times it may act as a base in the other solvents. I will give an examples in later. So HCl will be act as an acid in water solvent. Now if you take ammonia, aqueous solution of ammonia, aqueous solution of ammonia means NH3 plus water. What will form? All of you know, NH3 dissolve very much soluble in water, it will form ammonium hydroxide. So it will form NH4 plus and OH minus. So NH4 plus and OH minus. So OH minus is the anionic part of the solvent water. So ammonia will increases the anionic part of the solvent water molecules. So ammonia will act as a base in water. So what is the conclusion? So ammonia will act as a base in water. I think it is clear for all of you. Now moving to the another solvents. Another important solvent in liquid ammonia. Number 2, liquid ammonia solvent. So this is also auto-ionized to NH4 plus and NH2 minus, NH4 plus and NH2 minus. One ammonia molecules will abstract a proton and another one ammonia molecule will release a proton. So this is known as auto-ionization. So this is cationic part, and this is anionic part. So take examples of molecules and say for examples ammonium chloride. Ammonium chloride will dissociate to form NH4 plus and Cl minus. Ammonium chloride dissociate in liquid ammonia to form NH4 plus and Cl minus. So NH4 plus means Cl minus means NH4 plus is the cationic part of the solvent ammonia. So ammonium chloride will act as an acid in liquid ammonia. So what is the conclusion? Therefore ammonium chloride will act as an acid in liquid ammonia. So very simple. So we have to know the solvent ionization properties and the dissociation of the compound. So that is very simple. So if it will increase the cationic part, it will be the acid, and if it will increase the anionic part, it will be base. Say for examples, another molecules, potassium amide in liquid ammonia. If you take potassium amide in liquid ammonia, it will decompose to K plus and NH2 minus. So NH2 minus is the anionic part of the solvent ammonia. Therefore, potassium amide will act as a base in liquid ammonia. It is clear for all of you, I think. So this is very simple. I think it is very applicable also and very important part of the acid base theory. Now moving to the another solvents. Solvent number 3, liquid sulfur dioxide. One of the very most important solvent, liquid sulfur dioxide. So liquid sulfur dioxide will auto-ionize to form SO2 plus and SO3 2 minus. So this is cationic part, so acidic, and this is anionic part, so this is basic. So SOCl2 will dissociate into SO2 plus and SO3 2 minus. Say for example, a compound, we are taking a compound, say SOCl2, phenyl chloride, it will decompose to SO2 plus and 2Cl minus. So SO2 plus means the cationic part of sulfur dioxide, liquid sulfur dioxide. So SOCl2 will be act as an acid in liquid sulfur dioxide. So SOCl2 will act as an acids in liquid sulfur dioxide. Okay. Now taking another examples of basic compounds, say sodium sulfate sodium sulfite Na2SO3, it will decompose to 2Na plus and SO3 2 minus. So SO3 2 minus is the anionic part of the solvent liquid sulfur dioxide. Therefore SO3 2 minus, therefore Na2SO3 will act as a base in liquid sulfur dioxide. So this is also very simple. So just to remember this theory, just to understand this theory, you have to focus on the auto-ionization part of the solvent. If you know the auto-ionization part, that is the cationic part and the anionic part of the corresponding solvent, so it will be very simple for you to determine whether the compound is acidic or basic in that particular solvent. So now moving to the another examples of solvents. Liquid HF solvent, liquid hydrogen fluoride. So liquid hydrogen fluoride is a very important class of solvent. A typical solvent. It will be ionized like that. H2F minus plus HF2 H2F plus HF2 minus. So this is the cationic part, cationic, and this is the anionic part. So any compounds will decomposes to these solvents will form H2F plus, that will be acid, and which will form HF2 minus, will be base. Say for examples, if you take PF5 in HF solvent, all of you know phosphorus is the group 15 elements. So it is the valence electrons of 5 valence electron. It is already donated, but phosphorus has vacant orbital, so it can accept F minus ion as a ligand. So it will form PF6 minus, and this H plus ion will be combined to form H2F plus. So H2F plus is the cationic part of solvent HF. Therefore, PF5 will act as an acids in HF. Take another examples. Say for HClO4, all of you know is very strong acid in aqua solvent. But if you take in HF solvent, what will happen? It will form H2ClO4 plus and HF2 minus. It will form H2ClO4 plus and F2 minus or H1. So it will form the anionic part. It will form the anionic part of the solvent HF minus. So HClO4 will act sorry, there is a mistake. I'll rectify it. Just I am removing this part. So PF5 will act as an acid, but if you take HClO4 in HF solvent, it will form ClO4 minus plus H2F plus. So H2F plus means it is a cationic part, so therefore it will act as an acid. Say another examples of basic compound. So for examples, Kf is taken in HF, it will form K plus and HF2 minus. So HF2 minus means it will increase the anionic part of the solvent HF. So Kf will be act as a base in HF solvent. So this is very interesting properties of this is very interesting theory of acid and bases. You may take different types of solvent. You will auto-ionize and take any compounds to this take any compounds and ionize the compound. If it will increase the cationic part of the solvent, that will be acid, and if it will increase the anionic part of the solvent, that will be base. So today's class is ending now. So today's class is basically on the solvent system theory. I think it is very much clear for all of you. I have just taken few examples. There are so many examples of acids and bases in these categories. You may study in your books. So students, please listen carefully and study and focus on this theory by these classes. And already we have learned in these three classes Lowry concept theory, Arrhenius theory, Lewis acid base concept, and today is solvent system theory. So the fourth theory you have already learned. There are one more theory, I think, that is Lux flux concept. I will be taking this next classes. So till now, take care of yourselves, and if you like the video, please share, subscribe, and don't forget to make a comments. It may be positive or negative, doesn't matter. Thank you all for your kind presence.